everyone, and welcome to your Molecules in Motion lab. So the first thing I want to make sure is that you guys have your Molecules in Motion lab downloaded or printed off so you have access to it. So make sure you do that before you keep watching. The first thing I always do when I do a lab is I read through the activity and make sure I have all the materials and I know what I need to do before I do it. So our question to investigate today is the speed of water molecules different in hot and cold water? So we're going to be taking a look at that. We're going to pretend our food coloring are our molecules, and we'll have hot and cold water in just a minute. Materials for each group: hot water and cold water, which I have access to. I have my 2 cups, and then I need food coloring, yellow and blue, which I have. Now it says you need droppers. Most of your food coloring should already have a dropper attached at the mouth, so you shouldn't need any droppers to help you with this. So my procedure: with the help of your partners, which you might have a partner at home, feel free to grab a family member. Use droppers to carefully place 1 drop of yellow and 1 drop of blue food coloring into the hot and cold water at the same time. Now I'm by myself, so it'll be just a couple seconds off, but it'll be pretty close. Step 2, allow the colors to mix on their own as you watch them for a couple of minutes. And then we'll go through and fill out our lab report. So some things we're looking for today is we want to look and be able to describe what the colors looked like as they moved and mixed in the cold water, what they looked like and how they moved and mixed in the hot water. And then what that tells us about the speed of mixing colors, what that tells us about molecules in hot and cold water. So we'll talk through those. So let's get started. The first thing I need is I'm going to need some hot water and some cold water. So I'm going to go fill up my cup with cold water first. And I'm gonna look to make sure that I have, or to see how much water I have in here. So I'm gonna wait for it to slow down a little bit. I'm kind of in between, so I'm gonna go dump a little bit out. All right, I'm gonna let that settle. I'm gonna get down to measure it, and I have 1 cup of cold water. So I'm going to, actually that's not even that cold. I'm gonna redo that. And while I actually run my cold water, I'm gonna grab my hot water. I used a tea kettle. You can heat your water up in the microwave, over the stove, or just let your tap run for a minute to get some hot water. All right, so I have 1 cup of hot water, and I'm actually gonna pour that, and I'm gonna let you see, into my hot cup. Please be careful when working with hot water, especially if it's been boiling, because it will burn you. All right, and I have my cold water now, and I'm gonna dump that right into my cup. I measured to make sure I have 1 cup of each. And so they should be fairly even. All right, the next step of our lab is we want to mix in 1 drop of yellow and 1 drop of blue into each cup. I'm gonna open up my food colorings. And I'm gonna try to do 1 on each side so they'll start out far away from each other. So 1 drop of blue, drop of yellow. I'm gonna add 1 drop to the cold and 1 drop to the cold. So we're gonna take a look at how they're mixing together, and we're gonna wait a couple minutes. So I want you to observe and see how they're mixing, how fast they're mixing. Maybe one is mixing faster than the other. I'm gonna check the time. We're at 5 minutes, so I'm gonna let it mix for about 2 more minutes. All right, so it's been about 2 minutes, 2.5 minutes maybe, that I've allowed the molecules to mix together. Oops. So now we're gonna take a look at our lab report, and I'm gonna pull mine up, so make sure you have yours handy. The first thing we're gonna do is describe what the colors looked like and how they moved when they mixed in the cold water. So we're looking at our cold water cup first. What were some things that you noticed? Right, when I mixed these two, they kind of stayed separate. They moved really slowly. It took them a lot longer to mix together. And even if I look at it now, my blue and my yellow are still kind of separated, and they've only met a little bit in the middle. So I would say that my molecules probably moved, they definitely moved slower in the cold water. Let's take a look at our hot, describe what the colors looked like and how they moved and mixed in the hot water. So taking a look at our hot water cup, what do you notice right away? That's what I noticed too. It's definitely a lot greener. The colors mix together a lot faster in our hot water. They almost immediately, when I put the food drops in, mixed together or started moving towards each other. And they've mixed more evenly. It's hard for me to see the differences in the color. It's hard for me to see yellow, blue, and green. Where in the cold water, I can still see some yellow, I can still see some blue, and then I see the green where they kind of started to mix together. So make sure you write down your observations and descriptions for questions 1 and 2. If you need to pause the video to finish filling in your descriptions, please do so now. All right, let's take a look at question 3. What does the speed of the mixing colors tell you about the speed of the molecules in hot and cold water? So first, let's answer the first question, which really is asking, which one mixed quicker? Right, my hot water mixed a lot faster than my cold water. My cold water still isn't even fully mixed. So, what does that tell us about the speed of our molecules when they're in hot water? Right, it tells us that molecules in hot water move a lot faster than molecules in cold water. So for question 3, you're going to want to write that molecules in hot water move a lot quicker than molecules in cold water. And we know this because we could tell by how the colors mixed. Question 4 asked, there were several variables in this experiment. Amount of water in each cup, type of cup used, number of drops of food coloring, and when coloring was added to the water. So pick one of these variables and explain why you made sure it was kept the same in the 2 cups. So one thing we did, we weren't able to drop them in at exactly the same time. So we can't write about when the food coloring was added to the water, unfortunately. But we do know that I put 1 cup of water in each cup. I used the same type of cup, and I used the same number of drops in each cup. I think I'm going to write about the food coloring drops. So I know I used 1 drop of each in the cups so I could have a better picture, or I could see clearer how the 2 colors were mixing. If I added more drops to 1 cup than the other, I was scared that they might have mixed too fast or they would have mixed differently. So I made sure to only add 1 drop to each cup so it would remain the same. That wouldn't be a variable I had to worry about. Question number 5 asked, based on your observations, fill in the blanks with the words increase or decrease. So the first one says heating of substance blanks molecular motion. So did my hot water, did that help increase or decrease my molecular motion? You're right, that helped increase. So in that blank, I would put increase. Now, cooling a substance blanks molecular motion. Does it increase or decrease my motion? You're right, it decreases. This one definitely moved a lot slower. As molecular motion increases, the space between molecules, does it increase or decrease? Did my molecules stay separate or did they come closer together? Right, we know from watching our videos on gas molecules that the space between the molecules increases. They're moving all over the place. As molecular motion decreases, so as our molecules slow down, the space between molecules, does it increase or decrease? Think about those solids we've been looking at. You're right, it decreases. All right, so question number 6 is going to ask you to draw a model of the molecules in the hot and cold water. So in one box, you're going to use circles to represent the molecules in the hot water. And then in the other box, you're going to draw a picture to represent molecules in cold water. Now remember, as things heat up, the molecules separate and they move a lot faster. And remember that in cold water, our molecules are moving much slower and are much closer together. So use that to help you draw your pictures. And then finally, it asks you to take it further. There's a challenge question at the bottom of your lab, number 7. I'll read it with you, but I want you to use what you learned today about hot and cold water to answer that question. Using what you know about the attractions between water molecules and the way heat affects molecular motion, explain why the volume of water in the cylinder increases when it's heated. So think that one through. Do your best to answer that question. If you need to go back and rewatch part of the lab, for you to write down your descriptions or to answer some questions, please feel free to do so.